back to the lecture series in bioelectrochemistry. So, we are into the 4th week and we are starting the first lecture of the 4th week. So, if you recollect, the last lecture was about the concentration cells. We talked about it, how you can translate the Nernst equation for the biological cells. So, today what we will do, we will go one step ahead now. We will talk about some of the electrodes and relevant potentiometry. So, when we talk about potentiometry, the word which evokes in your mind is a potential, anything to do with potential. Potential means voltage. So, there are two parameters. When you look at Ohm's law, V is equal to I R. So, essentially potential difference, potential V is equal to I, which is the current, and resistance. Okay. So, there are only two parameters which you can vary or you can measure. Either you measure the potential or you measure the current. When we measure the voltage or a potential, everything falls under potentiometry. When we measure the current, they fall under amperometry or current measurements, different set of electroanalytical techniques. So, at this point what we are talking about, if you look at, we are always talking about potential like E0, E. So, all the measurements are about potential, we are not talking about the current measurements, right. So, in terms of the potentiometry, the critical aspect is what are the different kind of electrodes what you are using. So, by this time you must have realized one of the major important thing for any kind of measurements of these kind of electroanalytical samples or electroactive sample is the reference electrode. So, we talked about the reference electrode, then you have indicator electrode on which is being used to measure something. So, in terms of the reference electrode, we talk about hydrogen electrode. You know what is the challenge of an hydrogen electrode as a reference electrode which you keep at 0? You cannot have such a, so think of a practical situation. You cannot carry a hydrogen cylinder with you all the time to have your reference. So, you need a simple electrode which could be used as a reference electrode. So, what people have done over the years, there are two different kind of reference electrode which have been derived with respect to the hydrogen electrode. So, what you can do, you could have hydrogen. So, logically think of it. So, I say hydrogen as 0, fine, hydrogen electrode as 0, we have already talked a lot about it. Now, I take another half cell where I have AgAgCl, and based on that I measure the potential. So, now I say based on this potential with respect to hydrogen electrode, AgAgCl electrode is X potential. Now, I use AgAgCl as my reference with that value of this condition. Now, with respect to that I can always calculate. So, that is how is the concept of reference electrode became using AgAgCl as a reference electrode. There is another kind of reference electrode which is being used, which is called Calomel electrode. We will talk about it. So, these are the two reference electrode we will talk about. Then we will talk about the indicator electrode at two different platforms, one metal electrode, the other one is ion selective electrodes. And so, give you a brief idea. When you talk about the metal electrode, we talk about the redox reaction happening on the surface of the metal. So, for any kind of potentiometry, you needed to see a change in potential at the electrode surface. It can happen by some oxidation or reduction reaction, some redox chemistry, or it could happen in the case of ion selective electrode by binding to certain ions across a membrane or something like what you have seen in a biological cell. You have seen in the biological cell out here, if you look at it. So, across the membrane, if you have a specific binding of a molecule, something will come to that. Okay. So, these are the kind of things what we are going to discuss today. Okay. So, to start off with, so we are into week 4, lecture 1, and summary, this is lecture 16. So, indicator electrode. So, we talked about the electrode types. So, you have indicator electrode, which is one which respond to analyte activity. Then you have a reference electrode, which is your fixed reference potential. Okay. With respect to this, you are doing all the measurements, and the use of electrode to measure the voltage that provide chemical information. The use of electrode or use of electrodes to measure voltage or measure voltages that provide chemical information is called potentiometry. So, anything pertaining to potential or anything pertaining to measurements of voltage is called potentiometry. In the simplest case, analyte is an electroactive species that is part of the galvanic cell. An electroactive species is one that can donate or accept electron. So, in the simplest case, an analyte is an electroactive species, okay, which essentially either can accept electron or donate an electron. Okay. It could be either a beggar for electron or a donator of electron, and electron which respond to analyte is called indicator electrode. Okay. Indicator electrode. Now, reference electrode, as we talked about, we have talked about hydrogen reference electrode, and I told you that the problem or the challenge of hydrogen reference electrode. And now, we will talk about the next silver chloride reference electrode, which is also in short called AgCl reference electrode. So, AgCl reference electrode, silver chloride electrode, is basically it is a half cell. Okay. So, this electrode is reconstructed as a thin tube that can be dipped into analyte solution. Okay. So, essentially the way it looks like is something like this. You have I am just showing you the cross section of it. Okay. So, this is how it looks like. There is a out here there is a porous plug, AgCl electrode, and Ag wire bent into a loop. Ag wire bent into a loop. Okay. Aqueous solution of saturated with KCl and AgCl. So, this is your aqueous solution saturated with KCl and AgCl, and underneath what you observe here is solid KCl plus some AgCl, solid KCl and some AgCl. Okay. And out here there is a porous plug porous plug for contact with external solution. Okay. Air inlet to allow the electrolyte to drain slowly through the porous plug. So, this is the porous plug, which is kind of a wear inlet, air inlet, and this is the wear lid. Okay. This is how a AgAgCl electrode looks like, and silver chloride and calomel reference electrode are used because they are convenient. Okay. The standard hydrogen electrode is difficult to use because it requires hydrogen gas and freshly prepared catalytic platinum surface that is easily poisoned in many solution. So, now after showing you this picture, I wanted to go to the standard reduction potential of AgCl Ag couple. If you look at it, is around 0 plus 0.222 volt at 25 degree centigrade. Okay. This would be a potential of silver chloride electrode if this is the potential of silver chloride electrode if provided activity of chloride is unity. Okay. This part is very important, but the activity of chloride in a saturated solution of KCl at 25 degree centigrade is not unity, and the potential of the electrode is 0.197 volt with respect to the SHE or standard hydrogen electrode at 25 degree centigrade. Okay. So, now when I write this, you have to write it like this: AgCl, where AgCl plus electron makes it Ag solid plus Cl minus, where E0 is equal to 0.222 volt, but in a saturated KCl this is 0.197 volt. The problem with reference electrode is that the porous plug becomes clogged. Okay. So, the porous plug, these are some of the practical problems you will come across. This plug is getting clogged. There are clogging problem, thus causing sluggish unstable electrical response. Some designs incorporate free flowing capillaries in place of porous plug. Other design allow you to force fresh solution from electrode through the electrode analyte junction prior to the measurements. So, mostly these double junction reference electrode, where the inner electrode and outer electrode you have, solution of the outer compartment is compatible with analyte solution. Say for example, if you do not want chloride to contact the analyte, the outer electrode can be filled with KNO3 solution, the inner and outer solution slowly mix. So, that the outer compartment must be refilled periodically with the KNO3 solution. Okay. So, these are some of the very first reference electrodes which get away from the hydrogen electrode or standard hydrogen electrode. So, the idea is that if you use this value with respect to SHE, then this becomes your reference point. Okay. Similarly, the next reference electrode is calomel electrode. So, calomel electrode is a mercury based electrode, where I am just putting the calomel electrode reaction first for you. AgCl2 solid plus electron making Ag liquid plus chloride minus, where E0 of this reaction is 0.268 volt, and this is basically the calomel mercury 1 chloride, which is calomel. Which is calomel. Okay. But if this is in saturated KCl, the value becomes 0.241 volt. The standard potential for this reaction is as shown here, 0.268 volt. if the cell is saturated with KCl at 25 degrees centigrade, the potential is shown out here. Okay. Abbreviated as S electrode with KCl and is called saturated calomel electrode, SCE. Unlike SHE, which is standard hydrogen electrode, here standard calomel electrode. So, the C stands for calomel. The advantage of using saturated KCl is that chloride ion does not change if some liquid evaporates. So, you might be wondering why every time you are seeing the chloride ion is kind of out there, why everything is done with KCl. It is a practical significance of it is that KCl is that chloride ion does not change if some liquid evaporates. So, remember this, and what you can do, you can always do voltage conversion between different reference electrodes. For example, if an electrode has a potential of say minus 0.461 volt with respect to the calomel electrode, what is the potential with respect to silver chloride electrode? What would be the potential with respect to standard hydrogen electrode? You can always calculate it. Okay? And I wish you, so you remember this question and try to solve it by yourself. If the electrode has a potential of minus 0.461 volt with respect to calomel electrode, what is the potential with respect to silver chloride electrode? This is the question, and what will be the potential with respect to the standard hydrogen electrode. Okay. And in the notes you will have an answer to this question. Okay. Just you can cross check on the notes, but I will just leave it for you to work out. So, these are the two major electrode what I wanted to talk about, the standard electrode. Now, from here we will move on to the indicator electrode, the one which is sensing the analyte. So, let us move on to the indicator electrodes. Indicator electrodes. Now, the indicator electrodes, you will study the two broad classes of indicator electrodes. One will be the metal electrodes and the other one will be the ion selective electrode. Ion selective electrodes. Okay. Metal electrodes and the ion selective electrodes. So, ion selective, when we talk about the metal electrodes are the one which develop an electric potential in response to the redox reaction at the metal surface. Develop an electric potential based on the redox reaction at metal surface. This is about the metal electrode. On the contrary, when we talk about ion selective electrode, they are not based on, not mind it, not based on redox reaction or redox process rather. Instead, selective binding of one type of ion to a membrane, of one type of ion to a membrane, thus generating an electric potential. Okay. Thus generating an electrode potential. Okay. So, one which is metal electrode, which are completely dependent on your electrode based on the redox reaction at the metal surface. The other one is more like selective binding of certain cations or anions on a particular membrane surface. So, they are very different, and interestingly these ion selective electrodes are very popular in biology. So, I will give you an example of where valinomycin, which is kind of a cyclic peptide which allows the transport of potassium ion inside the biological cell, how the valinomycin could be used. Okay. So, we will talk a little bit more about these different kind of electrodes. So, we have talked about the reference electrode, and now we will talk about the indicator electrodes. Okay. And among the indicator electrodes, we will talk about the metal electrodes and the ion selective electrodes. Okay. I will close in here. In the next class, we will talk a little bit about these two different kind of electrodes, and then we will move about. From there, we will move to much of the current measurements. As of now, we are only talking about the measurement of the voltage or the potential, potentiometry. From here, we will move on to amperometry. Okay. Thank you.